everyone. Welcome to the November meet. And we are back again with three wonderful speakers. We have Yancy Kam, Priyam, and Ranjani on three different and diverse topics, starting with digital forensics to DevSecOps to supply risk management. All three are different topics and all the wonderful champions. I would like to give it over to Yancy to introduce herself. Yancy. Yancy, can you please introduce yourself?
I can totally hear you. I am just trying to start the video. Can you see me by any chance?
No, we can't see you.
Oh my God, that's something horrible. Oh, can I do this without video? Because I think settings gonna take some time. Will it be fine without that? I'm sorry.
It's fine. Go ahead. Please go ahead.
I'm sorry. I should have checked video beforehand, but I did not.
No
I'm
problem.
sorry.
Go ahead.
All right. So thank you, Vandana. Thank you, InfosecGirls, Girls, for giving me this wonderful opportunity. I'm really glad to be a part of this video session today. And good morning and good evening to all the people who are joining us today from both EST and IST zone. It's completely like 12 hours apart, so I know it's quite a pain. So I really want to thank all of you that you took out your crucial time for this. Today, I will be on overview of digital forensics. The idea is to let you familiarize with the concepts of this field. A little bit about myself. I'm Yancy, as Vandana thought about me, and I'm currently a PhD student at Purdue University. I've joined here in January itself, so it's around 11 months for me here. And my research area is in cyber forensics. As a part of it, what I do is I study cyber criminals. I create their behavioral profiles and I try to trace their identity. I try to understand why they do what they do. And I'm really passionate about it. I really see myself doing this for the rest of my life, and that's why today's session is really close to my heart. So all those women who want to pursue a field in cyber forensics, I would really encourage to all of you to shoot me all the queries you have in this field. Before that, I was closely working with a cybersecurity firm in Delhi, and I was head of training over there, and I was majorly responsible for delivering these cybersecurity sessions and looking over the pedagogy over there. I also worked with Crime Branch Delhi Police as a technical investigator, and I had an awesome time over there learning about how the crimes are happening in Delhi and how we could be instrumental in solving them. So yeah, I think that's a little introduction. Thank you, Vandana.
Thank you so much, Yancy. Now, we'll give it over to Priyam. Priyam, we would like to know about you. And I really like the way it was structured. The presentation was structured. Go ahead.
A very good evening, ma'am, and to all. Can you hear me?
I
Hello.
can hear you. I can hear you.
Okay, ma'am. So myself, Priyam, and I'm third year graduation student from WIT Dehradun. And firstly, I want to thank Vandana ma'am for giving me this opportunity, and I'm really excited for this. So few months back only I came and I became familiar with all this and I got a lot of interest. So I started exploring in the field of security. So yeah, I also gave talk this just last week, and yeah, it's very nice. And also, I'm infosec enthusiast, and I am now part of infosec girls community. So this is all about me. Thank you once again.
We are really glad. And especially, it seems amazing when the college students and the people who are in school are coming out and speaking. I remember in the last meet, you and there was a girl who was in school, 10th standard.
Um,
She gave a session, like Both of you were really amazing.
Yes, ma'am. Thank you, ma'am.
You're most welcome. Ranjini,
Hi, good evening.
good evening.
Thanks, Vandana, for the wonderful opportunity. Yeah, it's a big growing community. Is very nice to be part of this community. Thanks all. So I'm part of. I work with an Australia bank in the risk management team, and today's topic I'm going to talk about supply risk assessment. Thanks.
Great. Let's get started with your presentation.
Sure. Give me a minute. I'm just going to share my presentation.
Sure.
Can you see my screen? Okay. Okay, my topic is about supplier risk assessment. These are interchangeably used, called as supplier or vendor or third party risk assessment. So, in this today's session, I'm going to talk about firstly, we would like to know who is the first, second, third, and the fourth party is, what a supplier risk assessment is, the supplier risk breaches, and how do we prevent them, and also on how a risk assessment is done, what kind of considerations, risk rating, and etc. are to be kept in mind when we are doing a risk assessment, and finally, we'll conclude. So I'm not sure of the audience how well they are with risk assessment and risk management. So just to I iterate, what is the first, second, and the third party? We usually, interchange the words. We always say third party assessment or third party vendor or a third party supplier. So who are these first, second, and the third party? I think most of us would have this in our mind. We always say third party, but who is the first party? So first party is always our organization, and second party would be the customers of the organization or the members of the organization, the employees of the organization. So that would be the second party. Now, who is third party? Third party is an organization. When our organization outsources some activity to another service provider, that becomes the third party. Say, for example, I am a bank A and I outsource some developmental activity to a service company, company A. So, company A becomes the third party for my bank A. Do you get that relation? And coming to the fourth party, who is the fourth party? Now, company A, who is the third party for bank A, which outsources some of its services to another company. So, company B, say, let's say company B. So, company B becomes the fourth party. So, my organization is the first party. Third party is the organization to which I have outsourced some service. And the third party again outsources some other service to another company, so that becomes the fourth party. And this kind of keeps going on, fifth, sixth, seventh. So there's no limit on the number of outsourcer vendors or service providers that we use. So I hope it's clear, because this is very much important, the understanding of third party, because the entire topic revolves around third party risk assessment. Okay. So moving on, what is supplier vendor third party risk? Any idea what it is? Supplier, any supplier for that matter, always poses a challenge to any organization in terms of people, process, and technology. So when it comes to people, be it contractors inside the company, or working from outside, working from the vendor location, or within the company. So this they always pose a challenge or a threat to the organization. So what we would do is we would always rely on some third party background checks that is performed on the employees. So with terms of people, these are the challenges. With processes, coming to processes, each department or a division in a bank or an organization can manage the supplier relationship in a very different way. Say I'm one division manages the same supplier in different way, different type of data is shared. Another division using the same supplier may have another way of managing that particular supplier. So this again, and there may not be a central team which is informed that I'm using, my division is using this supplier for this service, the other division is using the same supplier for some other service. Then the IT or the contract management team may not be fully aware of it. This is another challenge to an organization. Coming to technology, sorry, coming to technology, it mainly revolves around the supplier connectivity based on how conveniently the connectivity between the organization and the third party connects, how the data is shared between the two organizations. So they would usually the supplier connectivity would be based mostly on the convenience and the IT process rather than the security requirements. So this is one of the major challenge that using of supplier risk assessment carry with. Some of the other challenges or risks that supplier or vendor third party uh, gives is about the entire the supplier or the company for the data lifecycle management. Who creates it or who manages it? The creation of data, who is the owner of that particular data, the usage, how much is the supplier given authority to use that data, how much is the usage. So nobody actually defines these kind of data usability or the creation or the storage, how long that the data at the supplier side needs to be stored, or how long it should be encrypted, what should be done. These kind of things pose a challenge to the supplier risk, to the suppliers or the vendor risks. Transportation, again, how data is transmitted between the two parties, and destruction as well. Their verification and validation of data destruction. Do you actually, when you outsource some part of your service to another organization, when you're coming out of the contract, how well do you, verify if the data that was shared, my customer data or my company data, is not stored or not being accessed by the vendor when you come out of the contract? Is it, have they really destructed it? Who's going to do this validation or verification? So these are some of the risks associated with using suppliers or vendors. Some of the other risks are also, having large organizations having different business units and operating in different geographical areas. Their regulations, the location specific regulations also, becomes a major risk. You need to comply with the particular country regulations if you have to be in the business. So these kind of regulations also apply, and there's also a major risk, uh, one of the major risks for using third-party suppliers. With all these risks, companies nowadays focus on having, spend a lot of dollars or a lot of money in implementing security. So what usually the organizations focus on? They would have very good information systems, or rather firewalls, antivirus systems, or malware detection systems, vulnerability management. So a lot of organization invest a lot on all these kind of processes. Also on, hiring a separate SOC team or a pen test team or a vulnerability assessments team. The organization spends a lot of things to actually look at the security posture of their own organization, but a very little would be allocated for testing and reviewing or monitoring of the suppliers. But being in this era, most of the companies use, outsource most of their services, around 60 to 70%. If there is a larger banks, there will be thousands of suppliers providing services to organizations. So very little amount or very little budget would be allocated for, testing or reviewing or monitoring these suppliers. So this is one of the major risks of you using suppliers. So organization need to focus most majorly on these kind of risks. So with all the risks known, now we move on to a few examples where recent vendor or supplier breaches happen. So how these breaches impact a company is what I would want to share with some of the examples. So one being something happened in 2019, early 2019, that is American Medical Collection Agency. This is AMCA early in is a third-party provider of billing services for large healthcare companies such as Quest Diagnostics, BioReference Laboratories. Health providers like AMCA hold some of patients' most sensitive data, which can be used by attackers for identity theft, for insurance fraud, financial gain, or even used for blackmailing people. So what did happen? The data breach actually took place from August 2018 till March 2019, and resulted in compromising the private information of about 20 million Americans, including where data such as name, date of birth, provider, and balance information, etc., was compromised. So, why is this notable? AMCA, which is American Medical Collection Agency, uh, lost its four largest clients because of these kind of compromise. 20 million Americans data was actually compromised. So AMCA had to lose out on its four largest clients actually, largest clients. So what happened finally? The companies filed numerous uh, cases against AMCA. They faced lot of enormous penalties and non-compliance with HIPAA. HIPAA is a healthcare regulatory requirement for any company dealing with medical information to be actually comply with HIPAA regulation. So finally, what happened to AMCA? AMCA had to file bankruptcy. So these are the huge penalties, and due to the breaches, supplier breaches, this kind of things could happen. A company had to come down. So this is one of the example. Next example is Wipro. Wipro being India's largest outsourcing consulting giant, in 2019, early 2019, had a major breach that sources said was caused by phishing attacks targeting numerous customer systems. It was initially believed that attackers was state sponsored, but later it became that it was primary goal to obtain cash. What usually happens is that, according to reports, at least one major US company had responded to this breach and had to come out of their ties with Wipro. So this is such a India's largest outsourcing consulting giant, which had to occur all these kind of a breach. So what I want to say is that supplier risk assessment becomes a major part when you are outsourcing some services or utilizing vendors or suppliers for providing services. You can refer to the link below for more details on the supplier breaches that has happened in the current year. And there are a few more. And in one of the latest survey conducted by eCentire says that about almost 44% of the firms that were surveyed had experienced a significant data breach caused by third-party vendors. So always we need to be careful on whom we deal with, whom we outsource our services to. So going with that, I would like to move on. What exactly is a supplier risk assessment? What is it? Anyone, you may want to comment and add your comments. Okay. Okay, let's move on. What a supplier risk assessment basically is. It's basically an audit of a vendor's processes, their financial health, to determine how much risk it poses to your organization. Due diligence is the investigative process by which a company or a third party review to determine its suitability for a given task. Basically, it's an ongoing activity which includes the review, monitoring, and uh, monitoring of the entire vendor life cycle. Okay. Why should we do this? It basically reduces the likelihood of data breach costs. The huge penalties, as I mentioned, the examples which I gave about AMC and Wipro, which incurred huge penalties for not complying or not assessing their service providers or third party suppliers. So basically, why we should do is to reduce the likelihood of data breach costs, reduce the likelihood of costly operational failures, So suppose some of the suppliers may be like providing a data service center. What if the data service center, the location of the data service center is so geographically located where it's always wherein earthquakes happen or floods happen. So usually, ideally, the location of a data center should not be in those kind of areas where it is prone to earthquakes or what you say floods or any natural calamities that can happen. So in such cases, your operations can be affected. So it which can cause so much failure, and your the impact of operational failures may be very huge. So such cases can be avoided if you do a risk assessment prior to providing, outsourcing your service to some service provider like this. Also, you could reduce vendor bankruptcy. As I mentioned, AMCA, which incurred huge penalties, had to finally file, bankruptcy uh, case. So, and also some cases, it may be a regulatory mandate to comply with, like in HIPAA or in, FISMA or any other regulatory requirement or OCC or any such regulations based on the geography where the supplier operates from. And also, it would be an ethical obligation because in case you want to deal with some other person, you also need to have that assurance that I can, provide outsource my service to this particular service provider. So these would be the reasons why we should go ahead and do a supplier risk assessment. Having all this knowledge, let's move on. The next one being what are the considerations, risk control, considerations that we should take into account before doing a supplier risk assessment? Risk assessment should be thought as an ongoing process. This cannot be thought as a one time process. So I select a supplier today and I leave it. I outsource all my data or my, whatever service that needs to be outsourced. I do it and I leave it off. I happily forget. Cannot be the case. It has to be thought as an ongoing process. You have to periodically review them, risk assess them based on any frequency. You can define the frequency and do it, but it should be thought as an ongoing process. And also, should conduct detailed information risk assessments wherein you need to get strong commitment from the upper management. Finally, the reason you need a strong commitment from upper management is because once you complete your risk assessments and you share your outcomes, there should be someone to sign off, and also should have a person to say yes, I will go ahead, or when you recommended not to go ahead with this kind of a supplier, you need to have that management commitment or to get those remediations completed, remediations signed off. So you need to have a strong commitment from upper management. Also, to define processes for all supplier access and data exchanges. You need to define the process within which you would share data to the supplier, the data exchanges, the protocols used, everything needs to be considered prior to selecting a supplier. So, and also you need to define a risk profile of each supplier. How we would do that, we would see in the coming slides. But we need to consider all this before doing a supplier risk assessment. Further, what is the process that needs to be followed? This is a picture. I'm not sure why it is coming up like this. Okay. Anyway, the process that is followed for a supplier risk assessment is first we analyze the current supplier database in the organization. We categorize them according to the services provider. Maybe some of them may be IT service provider, some may be just the resource provider, resource augmentation, or some may be just a physical space provider based on different categories. Some may be a SaaS provider, some may be a DR site service provider. Depends on the categories. You segregate them and categorize them, and then the next step follows. Then you can do a risk categorization depending on the data handle, the type of service, and the business process criticality. We categorize them, and also based on the threats to business, you categorize and rate suppliers. So this is the next step. Following that step, we perform what is called as supplier processes based on connectivity. As I spoke, we perform the supplier assessment process, and then we come up with a mitigation plan based on the outcomes of the supplier risk assessment. So this needs to be followed on this a life cycle, step by step process to complete, and this has to be consistent in the way we do. So next, what other things do we consider prior to performing a supplier risk assessment? The risk criteria. On what basis do you categorize suppliers? As I mentioned earlier, in the risk consideration, I mentioned that you need to categorize suppliers based on the type of assets, type of data handle, what are the assets, how much connectivity, how much does the service provider have access to my network, what kind of systems do they have access to, and things like that. So these are the criterias which you need to identify prior to coming up with a rating for a supplier. And also, one of the major other things would be the business process criticality. How long can a supplier not provide service? What would be the tolerance time? Would it be 24 hours or 4 hours, or maximum 10 days? How long can the organization sustain when service provider at a service provider's location there is a service disruption and cannot provide the service what was had to be provided? So these kind of process criticality we need to assess and have those ratings readily available based on performing the business impact analysis. We perform the business impact analysis, come out with business process criticality ratings, and then associate each supplier with the ratings for the assets, based on the assets and other things, as I mentioned. Next one, on the other one would be on the data handled and its classification. There should be a uniform classification of data across all the suppliers that an organization uses. So based on these category, we come up and perform a triage, or we perform a triage and then associate a risk rating. This we will see in the next slides. Prior to that, what we call as a supplier profile. Profile is something which again, as I mentioned, the type of service matters, description of service matter, how data is handled, what kind of contracts are signed, what kind of clauses are mentioned in the contract, security clauses. All these things become major input to build a supplier profile. Based on the supplier profile, we do, decide on the type of assessments that needs to be carried out for each supplier. Hence, this becomes a major step in the supplier risk assessment. Once all the data is collected, the data may be collected either through interview, discussion, or reading the documentation, or any such. You could go on site, talk to the supplier contacts. There would be always be a business partner or a business contact who would be associated with each organization. You could talk to them, interview them, and then collect all this information. Once you have all the information ready, now we are good to go with the risk rating. So this risk rating becomes a very important step in the supplier risk assessment. So risk rating would depend majorly on the classification of data and the business process criticality rating. Once we have these two, we triage and identify the risk rating. And risk rating can be classified either, it depends on each organization, but generally it would be critical, high, medium, and low. Anything till now? Are we good to go?
We are good to go.
Okay. So next, we're good with selection of assessment. So this is a very high level. Once we have the risk rating of the supplier, we can choose on the type of assessment, because not every supplier needs to have a full assessment, or not, or they can be different types of assessments. So generally these are the types of assessments followed in the industry, but these are customizable based on the organization. The frameworks that is for that the company usually follows may be different, but usually based on these type of assessments. So majorly I have listed out about three assessment types. One being a self assessment. This is purely a questionnaire based assessment, where just like in a checklist, where you share this across to the supplier, get them answered, and you do the review sitting at your own organization. This is majorly applicable for suppliers categorized as low risk suppliers. These suppliers, for example, what may be a low risk supplier? Something like a courier service, where where the data, the physical courier service, everything is packed and packaged, and they only collect the package from your organization and deliver it to your customers or members, or something like a mail. So where they do not have access to any of your systems, networks, nothing as such. It's just the physical package that they carry from one place to another. So that may be a low risk supplier. So they don't need to have an entire assessment completed. You may just have to have a background check of the employees who do this courier service or something like that. So that depends. So usually the low risk suppliers, we just carry out with a self assessment, which is a questionnaire based. The next would be a gap analysis. Now that most of the service organizations, they come out with third party audit reports called as the service organization controls report, the SOC reports, SOC 1 2 3 reports, which the service seeking organization, they generally provide this report and say, here we go, this is our security posture of our company, what kind of controls are implemented, what kind of controls are in place in my organization is already audited by a third party auditor. So why don't you use this? Instead of going, we as an organization going and doing another assessment, they would provide these kind of SOC reports, so that you have an assurance that some other third party has already audited this service provider and generated a report. What we do is we do a gap analysis against our control framework and see how well the security posture of the third party is. This kind of an assessment is usually qualified by a medium risk supplier, where with the data classification may be either confidential or may not be a very restricted data. So it's still fine, and this all depends on the business. If they are okay just to agree with the SOC reports, we go with gap analysis. Next is what is called as an on-site or a full assessment. These are very much exhaustive assessments which are carried out for usually for the high risk rated suppliers, very high risk rated suppliers. So this is an exhaustive one, where a supplier risk assessor goes on site, goes to the service provider's location and performs an assessment. So this would majorly last long for a day or a two, where the assessor goes to the organization, speaks to different departments, their information security professionals, interviews them, have a discussion, note down all the points, their assessment steps, and then come back. So we will look at those steps in the further slides, but I'm just giving you an overview. Once the on-site assessment or a third-party gap analysis, whichever we decide, the next step would be to come out with a control library, or define a control library. What this control library usually contains? This control library contains the controls that needs to be tested for a particular service provider. What kind of controls need to be tested? Does it have to be tested for a DE or a OE? What is a DE and a OE? I'll come to that. But and also, the type of controls that are decided to be tested also based on the contract that is written between the organization and the service provider. So it's an exhaustive library. Maybe around 60 to 70 controls may be scoped into the control library, depending on the type of service, data transmission method, information security clauses in the contract. Once we have this, we are now good to go, all set to perform supplier risk assessment. I know this is a very exhaustive process, and takes a lot of time. Each supplier assessment, at least for an on-site, would take a minimum 3 to 4 weeks, because you need to have your background work done, and then next phase would be to go for an interview with the supplier contacts, and then the risk assessment part, which we'll see now. So in the on-site, we perform what is called as a design effectiveness and an operating effectiveness of these controls. Design effectiveness assesses how good the design is operating, how good the control implemented at the service provider. Is it operating good? Is it effective, ineffective, not working well, or working well? We do that by selecting a single sample and see the effectiveness of the control implemented or control in place at the service provider location. Once we say that the design is effective, design is passed, the control is working well, we for some of the controls we also perform operating effectiveness test of the controls. As an example, where do we perform operative effectiveness? Say, for example, a data center. At a data center, the minimum required controls what we check are the physical security access. Who has access to the data center? Who has access to my racks where the service provider services from that particular location? So who can access those logs, or who can access that particular rack? Who can have an entry to the server to the data center? All these needs to be tested, verified, rectified, approved, and such things. These are some of the test steps for a control called physical security access. In these cases, the operative effectiveness of the controls would be assessed. The reason being, the design is effective, but what if the list of people who are allowed to enter the data center is not reviewed or recertified? The same list keeps continuing. So if an employee A who has left the organization still a part of the same list, somebody else could misuse and enter the data center. So though the design is effective, the operating of that control may not be effective. So in such cases, we perform what is called as operating effectiveness. There are many such controls, just as an example I gave you about the physical security access. So these all these design effectiveness and operating effectiveness would be performed at the on-site. The assessor would do both of these while he is present at the vendor's location. Some of the control areas that would be covered or would be tested are listed below. Major ones, we would also look at subcontracting, where I outsource to a third party, and if the third party has outsourced some of his services to another fourth party or a fifth party, what are all the subcontracting clauses that the third party has? Because for me, the subcontractor or the third party would be responsible for all of his subcontractors. So if my data is breached by any of his fourth party or his third party, and for me it is my fourth party, I would ask my third party accountable for any of the data breaches caused by his third parties. So these are some of the clauses and control areas that we cover. Exhaustive one again. Um, we also look at pen testing, security reports, security monitoring, business continuity, and disaster recovery. Some of these are the controls that we would assess. Moving on, this is this is a worksheet that a supplier risk assessor would usually carry. Maybe the headings or the labels may change from each organization to organization, but these are generally the ones that an risk assessor does when he goes on site or does a supplier risk management, risk assessment. Sorry. So this is the sample worksheet. Sorry, what did I do? So once the assessor comes back from the supplier side after all, completing that exhaustive worksheet, he comes back to the organization, performs what is called as a reporting. So whatever the worksheet cannot be shared to the business owners and the contractor or the suppliers. The reason being, it's a worksheet. It's for the supplier risk assessor for him to assess the test steps that he has tested. That's for his reference. So from this, there would be a report which would be generated, which would be understood by the business partners, because worksheet may contain some technological terms which may not be very understandable by business partners or suppliers. So in that case, a report would generally provide an overview of the service provided by the supplier, the data handled by the supplier, how the data is transmitted to the supplier, all these kind of things, which gives a clear picture about the entire engagement of these service providers, which could be understandable by any business partners or anybody other than the risk management folks. So this is the deliverable what we usually have. after completing a supplier assessment process. The reports also contains the exposure ratings for control deficiencies. What would be the impact if this particular control deficiency, or if this control is not working? What would be the impact? What would be the risk? All these kind of exposure ratings would be identified and mentioned in these kind of reports. This is the deliverable for any supplier assessment process. So this completes the supplier assessment process. Reporting is the last part of the assessment process. So once we deliver this report, what happens next? We are also discuss these reports or share these findings with the business partners, the divisional head with who divisional head, or the department head who engages these service providers. We make them understand what this risk is in their language, so that they are the owners of these risks. Finally, the remediation of these risk would lie with these business partners. We usually call it as a closure call, wherein we also invite suppliers. We inform them on what all the control deficiency at their that we identified at their location, what are the compensating controls in place at their location, how this could be remediated, on what kind of action needs to be taken. These are all discussed in what is called as a closure meeting, where this entire report is discussed. So once this is done, what next? So the supplier would have to come up with a remediation plan, and his action item would be to remediate the control deficiency that we have identified. One major task for a supplier a risk assessor would be that whatever the findings he has identified at the supplier side, the supplier needs to agree to those findings. What if he says, no, your assessment is wrong, or no, we have these compensating controls, we do not accept these kind of findings? So it's a major challenge for the risk assessor to get an okay from the supplier as well as the business for the identified findings. This usually is a tug of war kind of a meeting, which is a tough meeting. But yes, at the end, you need to get an agreement from both the parties that these kind of risks exist at their location, and they have to come up with a plan. So this ends the supplier assessment process. But as I mentioned earlier, this is not just an one-time activity. This should be an ongoing activity. So the next one talks about what is called as a review process. So quarterly, or whatever may be the frequency of the meetings, you need to discuss about these risks identified and the suppliers that you deal with, and keep reviewing the process, keep updating the process, reconsider the IT risk considerations that we identified in the beginning step. If there are any changes in the regulations of that particular location, or if there is any new clause that has come up that the supplier has to adhere to. For example, the data privacy clause, which recently came up. So not many suppliers handling private information or private data were aware of such a regulation. So you need to educate those things to the business owners, and they in turn talk to vendors and get these kind of regulations agreed upon, and have these kind of controls implemented in case those controls are not in place. So this is a continuous process. You need to review those suppliers risks, if there are any new regulation or whatever it is. So this keeps on continuing. They have to review it and come up with a mitigation strategy, uh, come up with a risk summary plan. And somebody needs to keep revisiting these things. So coming to the end, what is the conclusion? So as I mentioned, identifying the key risk associated with uh, using a service provider is a major part of this assessment process. We need to consistently, we should bring out consistency in the way of planning and mitigating supplier risk. You cannot have different processes or different approaches for examining or performing risk assessments. For the type of suppliers that we categorize, you need to follow a standard process, so that it's easy for you as well as easy for the business, and easy for the suppliers as well, that they are aware what kind of requirements we have, and what kind of evidence they need to share, and these kind of things. So there should be a consistent approach, and a methodical approach for examining the risks. And also we need to come out with a framework which suits all the categories of suppliers. So in general, most of the companies follow a framework called a shared information gathering, or any such COVID process, or any such things. They have their own frameworks to manage the risks. But this should satisfy all categories of suppliers, be it IT service provider, or a product supplier, or a hardware supplier, or any category of suppliers. And finally, always with reviewing the process, and having an ongoing process, we could always improve on planning for the risk mitigation, which is very important. Just identifying the risk and not acting upon would not help the company nor the management. So always having a proper risk mitigation plan helps, and also adhering to the action item and closing those risks in the stipulated time frame always works. And this makes either a CIO or a CISO happy, and they could happily peacefully at least sleep. They know what the identified risk is, how much risk is associated with vendors or third party suppliers. So they kind of know the risk. And without performing these kind of supplier risk process, there is a lot of unidentified risk, which actually gives sleepless nights to either the CEO or the CISO. So with this, I conclude my presentation. If there are any questions, I can take. Any questions?
Yeah. Hi, Ranjani. We have a question. Do you use a tool to keep track or manage the control library?
Yes, there are tools available in the market, third-party tools available in the market. But we also, this majorly on Excel sheets, or SharePoints, or some GRC tool to track and manage these control libraries.
Oh, great. Um, I think we don't have any more questions. Uh,
Okay.
it was a great session. Thank you so much.
Thank you, Vandana. Thank you for this opportunity, and thank you all for joining in. And have a pleasant evening, and look forward for the other two sessions. Thank you so much.
Thank you.
Thank you.
So, up next, we have Priyam. Priyam, over to you so that you can talk about the session that you would be taking.
Yes, ma'am. Hi, everyone. Can you hear me?
Yes, we can.
Okay, ma'am. Are my slides visible, ma'am? Okay, ma'am. So, hi, everyone, and I welcome you all to my session, Dig Deep DevOps with DevSecOps Girl. So, you all might be wondering what is this DevSecOps Girl? It's my Twitter handle. And so, moving towards next slide. So and I have already introduced myself in the starting. I am third year graduation student from WIT Dehradun, and all I have told in the starting. So I have just started exploring in DevSecOps few months back. So firstly, I try to learn the basic, that is DevOps, and after that, I will be telling about DevSecOps in further sessions. So here is my Twitter handle in the below, and nerdsplayground.in is my blog. So let's come what all the thing who all are the audience for this. Those who are interested in the field of development, those who are interested in the field of security, and those who are interested in the field of operations. And if something is missing or anyone wants to add something, you can comment in the comment box. So let's move to the things we will be covering over here. Firstly, we will see what are the pain points, means what were the issues or problems which were faced when DevOps was not present. And then we will come to know about the waste or the skills which were getting wasted. Then the evolution of the software development from waterfall model to agile model and then DevOps. And then we will come to know the various things about DevOps, that's life cycle, how it works, use case, benefits, and its conclusion. So let's move to the next slide, that is pain points. In the pain points, we will be discussing what were the issues faced or what were the problems faced when DevOps was not there. Firstly, we will be covering serious outages. Serious outages here means the technical issues which occur. So there might be some technical fault or there is not proper power supply, so systems go offline. The people were not able to perform their job, so the production reduced or the production of the software reduced. And it was happening at a repeated instance, it was happening repeatedly, so due to which the there was no action taken to improve these issues. And also, the recovery was slow. And due to all these issues, the people developed low faith in the IT industry. So, I think first point might be clear. And now coming to the second point, no increment value. No increment value means that the projects were lengthy and the people were not getting paid something extra for it, or it was infrequent large batches, and no experimentation was done before the implementation, so it might cause some great errors. And now we come to third point, that is excessive infighting. Infighting here means conflicts. When there are various groups or teams working, they should communicate and they should share the ideas so that they are able to perform in a better way and produce more. They should not be like us versus them or little transparency. Due to these problems or these problems within the team, they had a lack of customer focus, and this due to this they were not able to satisfy the customers. And as a result of this, they were losing the talented people who can do great in the IT industry. So let's move to the next slide about waste. So we saw what were the problems occurring. Now we will be seeing that what were the skills or knowledge or the capital getting wasted. So waste is anything that takes time but don't add value. So firstly we will covering the knowledge waste. Knowledge waste is something when the people or the two teams are not sharing the knowledge or they are not communicating with each other, they are not sharing the ideas, so it they are not able to increase it or not able to share with each other. Due to this, knowledge waste was caused. Then we come to waiting waste. Like two teams are working, if one team is working, the other team is idle. It don't have something to process or work. So due to this uneven processing, the second team was not able to or not having the something to do, so their time got wasted or their knowledge got wasted. This was the second problem. Then let's come to the third problem, that is over processing waste. Over processing waste when we are not about clear about the agenda or we are not clear about the requirements, what are the requirements of the customers actually. So they used to process something extra which was not needed also. Now we will be coming to the motion waste. Motion waste is an unnecessary waste, like when two teams are working and they are at different places. So if one team is have all the facilities at the same place, so they can assess it at the same time and are able to produce the things. But if the other team having not all the facilities at that place, they have to take their project from one place to another place, so that all the technical things are done and all the arrangements are done. So this was the motion waste, where the time was being consumed unnecessarily in testing or other things or other processes in doing them. So let's come to the next point, that is inventory waste. Inventory waste is piling and piling of the things and not realizing the value. So there were a lot of work being collected up and they were not able to work on them properly. So if a huge amount of work being uh, collected and the people will not give their 100%, and if the 100% you don't give to something, then obviously you will not able to produce what is your capacity. And due to this also there were bunches hidden problems. So let's cover the last point, that is overproduction waste. So it sometimes happens that the company or the people, IT sector people, keep the staff and machine busy. Just to keep them busy, they produce unnecessarily the if it is not needed, then also because they want to keep them busy. And if the product is not needed in the market, then also. So now we are familiar with all the waste which were occurring. And so to overcome all these situations, there were many models formed, and we will be covering them one by one. So I evolution of software development. Firstly, I will discuss waterfall model, then agile model, and then we will come to DevOps. So let's cover waterfall model. I hope many of them might be familiar with it. So waterfall model is having 5 steps. Firstly, the requirement analysis and specification. Requirement analysis is when you gather the things or what all the requirements are there and what all are the things you want to make in the project. So firstly, we specify it. Then comes the design phase. In the design phase, we design what all we have gathered or what all the requirements we have gathered. We design it on a paper so that, or we make a roadmap so that it is easier to implement further. Then comes the implementation and unit testing. In the implementation and unit testing phase, it is actually the practical phase comes. Last two were the theoretical. We are doing it on the paper. And now we will start coding part and building the model. So over here we implement what we designed in the last phase. And along with implementation, the unit by unit testing is done, means in parts, in chunks. So after this, fourth step come integration and system testing. In integration and system testing, the system is tested at the whole and the progress of it is taken, and then it is launched in the market in the operation and maintenance phase. It is operated and go to the people, and after that it is kept maintained so that to increase the life of the project. This was all about waterfall model. So let's move. What were the issues or problems which were faced? That is waterfall challenges. So I have divided this in two categories as you can see in the image. Firstly is the problems faced by developers, and the secondly is the problems faced by operations. The developers face problems like they have a huge waiting time for their code get deployed by the operation field. And also the pressure of work was on old, pending and new code. And the operation field uh, got the problems like it was difficult for them to maintain the uptime of the production environment. Over here, I will like to tell you all that what is uptime. Uptime is the time when the system is working, the computer system exactly. So after that, we come to the tools to automate. So earlier time, there were not so many tools for the operation, but now it has increased. So it was less in number, and the number of servers also which have to be monitored also increased. Now the fourth point is that it was difficult that they organize and provide feedback. So the customers were not able to give their feedback. So without feedback, we can't improve the project. So to overcome these challenges or these issues, these problems, we formed or we make a new model, that is agile model. So I introduce you all with agile model, how it works. Firstly, it has 5 steps, that is design, building, testing, planning, and requirement analysis. This is the first iteration of the model. So, in the first iteration of the model, when it is the project goes in it, then it is given to the then after that the customers give the feedbacks, and according to those feedbacks, the project is improved, and the new if there is any new requirement, that is also added in the planning phase. Then the project goes to the second iteration, and same the feedback is taken, again improved, then goes to the third iteration, and it goes on till the whole project is prepared. So after we get the project, this is what all about agile model, how it works actually. So let's see what were the issues faced in this also. There are two set of pictures. Firstly, the first set of picture is showing how there was no problems faced in waterfall model. So in waterfall model, the customers and developers do not have the communication, and also the developers and operation field was not having the communication. So these were the three parts of the people who are not communicating with each other, and if they communicate, the better of a product would be formed. So in the second picture, I am showing how agile model reduce that challenge. The customer and software requirement and the developer and tester, they started to communicate. So the gap between them was reduced, and this was the solution was given by agile model to waterfall model. But still there was problem that the developers and operation field was not communicating. So to overcome this, we came with DevOps, and DevOps is the successor of agile model actually. So let's move further. Okay, so let's take DevOps. What do we understand by DevOps? DevOps is a set of practices. It's actually a set of practices that combines the software development and the operation part to provide a continuous delivery and software quality. So the delivery will be continuous now, and the quality of the software will also become high. This is what is the exact meaning of it. Moving towards the further slide, now we will see the life cycle of DevOps. In the picture you can see there are many parts. Firstly, we start it from planning part. Then over here we plan the vision of the project. Then we come to coding part. We code it. And then we come to building part. We build the project. After that we test it, and then we integrate it. When then we deploy it on the server, production server, and after that we operate it, and it is continuously monitored. So all this process goes continuously, and you can see that the life cycle shape is in the form of infinity. Infinity means it goes on continuously. So this is the life cycle. Now I explain you all the steps one by one and how DevOps work actually. Let's see in the further slide how DevOps work. Firstly, we will see the collaboration. So the problem of communication, sharing, and all was reduced by this, that is collaboration. So in the collaboration, the development team and operation team work together to get a goal, get a set goal. So there was transparency between the two teams. They also have a shared purpose, as I already told, and they work together, and also so this caused the empowerment. And by the collaboration, we not only mean that DevOps and operation team collaborate, but also all the teams, including the test, product management, and executives, they all work together so that the production is increased. And by this collaboration, we get the things done more rapidly, effectively, and efficiently. So, this was the good thing about collaboration. I hope you might be now familiar with collaboration. Now, let's move to the second point, that is automation. In automation, it DevOps relies heavily on automation, means tools for developing the various things. You need tools, so you can either build it or buy it. According to me, you should buy the tools rather than building it from scratch, because you should focus on what you are going to build your project. Now let's move to the third point, that is DevOps relies on tool chains to automate large parts of end-to-end software development and deployment process. So as all the processes we saw in the life cycle, there are a lot of tools which work one after another in the form of chain, which we will be seeing in the further slide. And it's true that DevOps relies on tools, but it's much more than that. So let's, after automation, we come to continuous development. In continuous development, it involves the planning and coding of the software. As in the below picture, you can see the plan and code together is called continuous development. So it is continuous development taking place, and the vision is decided during the planning phase, and the developers begin to code in the coding part. So there was no DevOps tools for planning, but there were a lot of number of tools for maintaining the code. The tool used for this continuous development process is Git, and there are also many tools used like Ant, Maven, Gradle, which are used for building, packaging the code into an executable file so that we can forward it to any of the next phases for further operations. Now, after continuous development, let's come to continuous testing. In the continuous testing, there are stages where software is continuously tested for bugs, for flaws, to remove them so that it works in a proper way. And also, there are many tools in this automation testing like Selenium, TestNG, JUnit, etc. And it also, continuous testing allows QAs, means quality assurance, to test multiple code bases thoroughly in parallel to ensure that there are no flaws. The tools, I like to tell you a little what they do. The Docker, it simulates the test environment. The Selenium, it do the automation testing. It's a framework. And after that, it comes TestNG. It generates the reports, and Jenkins is as a whole automate the entire testing phase. After continuous testing, let's come to continuous integration. In continuous integration, we write the code, commit it, and test it. There are three processes: code, commit, and test. After this, our project is ready and it's a working project. The developers require to commit the changes in the source code more frequently. After committing, the test is run automatically. So after that, it's the third point, that the early detection of problems, if they are present, is done, and the tool used is Jenkins. Let's come to the next slide, that is continuous deployment. In this, the code is directly deployed on the production server for release, and I will here tell you about the continuous deployment and continuous delivery. There is difference. In continuous delivery, the product is deployed on a mock server, but in continuous development on the source server, on the production server. And also, the people who are working in microservices, they believe in continuous delivery. And the example of this in the present time for continuous development is Facebook, and the tools used for it are Puppet, Chef, Salt Stack, and Ansible. And Now moving towards the next slide, that is continuous monitoring. So in the continuous monitoring, we continuously monitor the performance of your application, and the root cause of any issue is determined. It maintains the security and availability of services. And if there are any system errors such as low memory, server not reachable, etc., these are resolved in this phase and they are automatically detected. This is the good point of it. And the tools used are Splunk, Nagios, etc. So after this, now you all might be familiar with how DevOps work. Let's take an use case of DevOps. I will be giving you a real example of Facebook, how it implemented it. So in 2011, there were many features of Facebook launched like timeline, music, ticker, and it was deployed worldwide. And the features released was up to 500 million users. And due to this, a huge amount of release, there was heavy website traffic. And due to this, as a result of this, the server meltdown. So after this, there was one more problem that they were getting mixed responses from users, due to which they were not able to make any conclusion how to improve this problem or how to get rid of this problem. So they get out of one new technique, that is the dark launching technique. The dark launching technique usually have three steps. I firstly make you familiar with it. The first is that the new features are first deployed on a smaller and specific user base. First, we will deploy on a smaller area. Then, these features on the people on which they are deployed, they are continuously monitored and the feedbacks are continuously developed, and they are after continuously developed, they are tested also. After that, the third point comes that the features are stable. If we get a result after this feedback, continuous development and testing, if they are stable, then we deploy it on other user bases in multiple releases. So as a whole it is released. So I now show you how the Facebook implemented this dark launching technique. Over here you can see in the image there are three switches. One is first is on, the second two are off. So when they on the switch, it was deployed on a small area, and the continuous development was taking place. And over here, it was continuously monitored, due to which there was a continuous development and continuous testing done. And after this, when they get a proper feedback or better feedback, and it was properly deployed, they deployed to others also. The two switches which are off, they deployed it on a whole. So over here we came to know that the things or the features or the project work was continuously developed, continuously tested, continuously integrated, continuously deployed, and continuously monitored. So let's come further. So I have told you the example also. Now I will be telling about what were the benefits. Firstly is the environment stabilization. So earlier it used to be that the people were having the problem of not a proper system setup, or the uptime was not proper. So or the power supply cut was there. So to overcome all this, they come with DevOps, and it helped in increasing the uptime and it enforced consistency. The second point is shorter development cycle. In this, the cycle is short, so the production will be fast. And also, it manages the requirements and code repository. After that, it comes the third point, that is increased release velocity. In increased release velocity, there was continuous build, push button deployments, and it was released continuously, so the production increased. And after that, it comes reduced defects. The defects, as the automated testing was there, as you show, it was continuously automated. So the number of defects which are coming, they were solved at that point only, so the defects reduced. And then it comes process metrics. Process metrics is that we track both time at each stage and the errors and the exceptions. So there are a lot of benefits. I have covered some of them important ones. After that, we conclude it. So what is DevOps generally? DevOps is a software development approach or practice which involves the five processes, which is the continuous development, continuous testing, continuous integration, continuous deployment, continuous monitoring throughout its development life cycle. So all these processes I explained you, and you all might be now familiar with it. Okay, so thank you. This was all about DevOps, and I think it was useful to you, and you might all got about the idea of it. So thank you so much.
Thank you so much, Priyam. It was really amazing.
Thank you, ma'am.
Wonderful.
Thank you,
Tell
ma'am.
me one thing. Will
Yes, ma'am.
okay? There's someone who has asked that will there be any practical demonstration? Sorry for today. There will not be any practical demonstration.
Yes, ma'am.
Yeah. So we are moving on to the next speaker, who's Yancy Kem, and we'll give it over to her. Yancy?
Yeah, thankfully my video is working for now. If people can see me, can you see me once now? Hello. Yeah, can you see me now?
Yes, I can see you now.
Thank Okay, thank you, Priyam, for your session. And now I would be starting with digital forensics. Let me quickly pull up my slides and then we can discuss about it. All right, so as I mentioned that this presentation is going to be an overview about forensics. The idea is to let you familiarize with the concepts that may be helpful for women or men who wants to venture into this field. Forensics is comparatively a newer field, I would like to say. So there's a lot of questions around this field, like what are the standard operating procedures? What are some rules? What are some regulations? What are some federal procedures that we need to take care of? So that's all we are going to discuss today in today's session. And I hope that you really get to know a little bit about this field. I would welcome your questions over the chat, and you can always like pop me on the LinkedIn. I'll start with a little primer about cyber forensics. In this, I'm going to discuss a glossary about it, like a few terms which are mandatory and necessary to understand the rest of the talk. Then we are going to talk about states of data. Then we are going to discuss about network forensics, which is a very crucial part of any forensic procedure. Event log analysis and sources are something that every forensic investigator must look through whenever investigating. And then we'll finally conclude with anti-forensics detection techniques and methods through which an investigator can help the analyst to process the case. All right, so what is cybersecurity? I know it's a very cliche question, but I would like to start with it because then I'm going to draw a comparison between forensics and cybersecurity. So to be a good digital investigator, you must know how to play offensive, not just defensive. Therefore, in cybersecurity, we try to understand how these malicious actors uses electronic assets such as wireless LANs, LAN, printers, scanners, etc. It's like locking the doors at night in your home before sleeping so that no intruder can enter. So, knowing locks could be a preventive measure is equivalent to having cybersecurity measure in your organization. That is why individual organization, financial institution, and even universities implement these various security on their databases, networks, hardware, software, web, and firewalls at times to prevent any potential attack. Forensics, on the other hand, comes into the picture when an attack has already occurred. And you, as an investigator, is responsible for finding the five big W's: what happened, why happened, when it happened, where it happened, and how it happened. The goal is to apply scientific methodologies to questionable devices on the crime scene in order to extract evidence for use in a court proceeding. So how do we do this, or how do any investigator will do this? There's a standard procedure, there's a standard process model known as digital forensics investigation process model that we are going to see in the later slides. For now, I want you to notice how there is an ongoing relationship going on between cybersecurity and forensics. In a sense, you see, there is a continuous feedback cycle because security is going to tell you what assets and controls were in place before the attack on your organization or any environment that we are focusing on, that how that attack happened, while the forensics is going to tell you, since those controls and those assets were in place, here's the bug found through which the attacker came inside the system. And so now you have to report the POC, the point of compromise, and everything. Like every other scientific discovery, forensic sciences also have a father, and he's Edmund Lockhart for us. He said, as a perpetrator enters into the crime scene, his every contact will leave a trace. What he's essentially trying to say is that even the perpetrator's footprints, as it comes in contact with the bare floor, will leave a trace and may be used as a evidence. So, in the context of digital forensics, if we want to really make out the meaning from Edmund Lockhart's principle, we can safely say that artifacts of electronic activity in digital devices are detectable through forensic examination, although such examination might require access to computer and network resources involving expanded scope that may involve sometimes more than one geolocation. Because I'm sure you might have heard that there are cyber attacks happening, which does not only span in one country. Sometimes the attack starts from Russia and it expands to USA. Sometimes it like takes all these multiple countries, and that's why while we are investigating these kind of attacks, we have to take care of these geolocations and their corresponding federal rules. So this is the major and most important step of major slide of the entire presentation. This is the digital forensic investigation process model. Whenever there is a cyber crime to be investigated, you as a forensic investigator have to follow a standard digital forensic investigation procedure, that is identification, collection, preservation, examination, analysis, and presentation. This model is particularly given by DFRWS, which is Digital Forensics Research Workshop. It's a nonprofit volunteer organization dedicated to bring together everyone with a legitimate interest in digital forensics to address the emerging challenges of this field. So, if you are a budding engineer or a practitioner or a researcher, I would highly encourage you to go to the DFRWS, look their agenda, you can publish your results if you have any, or that's a good start. Right. So the very first step, identification, is something you begin before any investigation. What I'm trying to say is it's essential that the investigator knows what regulations apply to a scientific investigation in order to not to damage or destroy a case by failure to abide by rules. So this involves finding about the case you are handling. Of course, no case is directly handled or should be accepted by any investigator just like that. He or she must sign proper documents first by determining the scope of the investigation. So as you can see in the slide, there are four important steps. The first one is to determine the scope of the incident. You need to investigate whether the investigation scope is just at this crime scene, or do you have to investigate the entire organization, or just the internet has to be looked at. Sometimes these attacks, could involve inter and intra geographic locations, as I mentioned before. You need to also assess the case. You also need to assess the nature of the case. By nature, I mean if it is an internal case or a civil or a criminal investigation. Internal case could be it would be something which is internal to an organization where you work with the management, and this kind of case is something which is least restrictive of all the inquiries you will ever do. Your target won't even know that he's being or she's being the target until you are finished. Civil investigation, on the other hand, is where the intellectual property rights are at risk. For example, the recent Capital One attack, where financial data of more than 100 million customers were affected, is one of the civil investigation cases because the financial data is one of the IPR data and it was at huge risk. So, any investigator who is going through such kind of investigation must be cognizant of federal law of civil procedure of that country. The third category of the case could be a criminal case, and it majorly involves computer as a primary source to target. For example, there's child pornography, counterfeiting, cyber stalking. So investigators in these kind of cases are expected to be aware of the federal rules of evidence, aware of the strict legal and constitutional restrictions, because failure to abide by these laws will most almost certainly result in evidence being suppressed, and it doesn't matter how much you have done the effort to solve the case. Since your evidence is tainted, it won't matter anymore. You also have to look at the characteristics of the case. Like from the initial point of view, you have to find out if it is simply a case of intrusion, or is it a denial of service kind of attack? Is it a malicious code or malicious communication, or maybe just misuse of resource? The second step in the model is collection. And I would say it is the most technical part of any investigation procedure because, first of all, it requires obtaining the search authority. Then you go on to collecting digital evidence that may be relevant to the investigation. Remember, if the case under scrutiny ever goes to the trial, the investigator must be able to prove the authenticity of the data all the time. So, if you have to perform collection procedures, you have to do it very, very carefully. I cannot stress enough that you have to photograph the area, you have to record what's in or what is on the screen. If you see the systems are live, just take the pictures of what you could see at that time. You maybe create videos, but just try to capture the crime scene as much as you can. Identify sources of data. Like these sources could be a firmware, a network, maybe a disk, memory, software, anything. So if you see that, if as you enter into the crime scene and you see that there are certain systems which are live, you have to make sure that you do not turn them off by any mistake. Well, the best procedure is to perform a memory dump. And if you see that there are systems which are being shut down, you also do not want to turn them on. So you perform imaging, which is a forensic concept, and we are going to discuss this in the detail in the later slides. So this is the most important thing. While you are collecting the data, it is important to maintain the chain of custody. So from the time the evidence is first seized by a law enforcement officer or any civilian investigator until the moment it is shown in the court, COC or chain of custody is a fundamental document and is applicable throughout the computer forensic process. It could be a printed or electronic document, and it will essentially tell you about the acquisition, custody, and transfers related to any piece of evidence. Acquisition, as in who acquired the evidence, when and where the evidence was acquired, and what method was used for its acquisition. Custody, as in who had the possession of the evidence, where was it kept, what method was used to store it, and how long it was kept. For example, if you let's say if you have seized a hard disk and there is a constant fear of static electricity around the hard disk, it's not a very good procedure, or it's not a very good measure to keep it in open. So you might have to keep it in Faraday bags, or a bag which is safe from electromagnetic waves. Next is processing. So what was done to the evidence? Did you start working on the evidence right away, or did you first make a copy of it? Did you do the cloning? As I was saying, that imaging and cloning are almost the same concepts, but slightly different. But we are going to see how. Transfer. Transfer of the evidence from one possessor to another, like recording along with the signature of the new keeper. Sometimes when you move from one legislation to another legislation with those evidences, you have to take care who's the new keeper of this evidence. And that is why keeping a track of transfer records in a COC is essentially important. Finally, fate. Like, what did you do with the evidence? Did you delete it, like securely delete it, or did you just destroy the evidence just because it wasn't relevant to the case? Or did you return this evidence to the owner itself? Please know that a forensic investigator must be able to show a chain of custody all the times. Failure to do so will actually can lead to evidence being excluded from the trial. Now, the first step, identification and collection, and the third step that we're going to see now is something that happens on the crime scene. And we have little kits with us as a forensic investigator that we always carry with ourselves. Let me try to see if I can share my screen with you, and I would like to show you how those kits are. So these are called Freddy kits. It's FREDDIE. And these are just little black boxes which contain all these wires and all these connections. So just in case they have any different kind of devices or computers on any removable media, these can be applied, or these can be connected with these sort of wires and can be put to, collection through these mini computers. So this is what is generally carried by forensic investigators on the crime scene. All right, going back to, so after you collect the evidence, there are certain important steps that, or certain important things that an investigator should keep in mind. I would like to emphasize again and again on documenting everything in the chain of custody. So that's why my first point is to document, 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 lawfully capture evidence. See, when you enter into the crime scene, it's not just about collecting, it's also about did you follow the correct procedures while you were collecting those evidences. So you take photographs because photographs can never be neglected when you show them in the court of law. And it always helps the analyst as well when, after the collection has been done and now it's time to do the examination of this evidence. So taking photographs and taking videos can really help out. Make cryptographically verifiable copies. See, you cannot start working on an evidence directly. Why? Because there is a big chance that you can taint the evidence, you can destroy the evidence just by opening it. You are changing the last modified date of maybe a document if you're opening onto a system, right? And you don't want to do that. So we have procedures how can we prevent this thing from happening. One of them is to make verifiable copies. Like, you have to make copies so that you can save these copies onto your systems or onto the Freddy kits, uh, and it would be helpful for you after you collect those evidences. You can run multiple analysis. Sometimes when you run single analysis on these data points, the result do not come out, so you might have to run different sort of analysis. And that's why if you have copies, you can always run this data again and again. Set up secure storage of collected evidence. It means prevent your evidence from any electromagnetic interference, as I mentioned before. In the next step, that is preservation, that we are going to see, we are going to look how we can set up the secure storage. Establish chain of custody, as discussed in the previous slide. You have to analyze copies only. Never work with the original data itself. It does not fall under the law of procedure, and it is also not advisable in any case. Use legally obtained and reputable tools. So this is important because we are in an age where we try to, go to Google, try to find out freewares and try to use them up. But when you are a part of an investigation, and when there is a huge chance that this a case may go to a court of law, you have to also follow those tools which are, given a node by the court. So that is why N-case forensics is one of the tools which is majorly used in any sort of digital forensics procedure. Autopsy is one of them, but it is an open source tool, and any investigator wouldn't really go for it. But as a student, if you want to go ahead and do your own analysis, if you want to see that how NCase works, autopsy will give you a good feel about it, right? Documenting every step is the same thing. So preservation, as important as collection phase is to us, it is equally important to preserve the data to maintain the integrity of evidence. It could prove to be tough at times because when you seize the hard disk, there's always a risk of static electricity, right? You must know what an electrostatic bag is, what a Faraday cage is. It basically it doesn't allow electromagnetic waves to really go enter into it. If you have seen the series Mr. Robot, it has this very nice footage where it shows that how this person brings hard disk and gives this to a person, and he enters into a Faraday cage and then try to analyze it. So yeah, that's one of the cases. Because this is important, because if a suspect is aware that the drive is going to be seized and at some point in future, he might try to do something to wipe it, right? So please note that if this preservation step goes wrong, rest of the case really doesn't matter. The evidence won't be forensically sound and so won't be admissible in the court of law. You could be a best analyst or could be a best hard drive analyzer, but if you are dealing with data which is tainted, which is not forensically sound, rest of the stuff will be pretty much useless. So if you are leading an investigation or investigating yourself, you must tell people that there is no coming back from messed up or flawed collection and preservation step. So you might have to deploy multiple techniques on a crime scene. I would say some of them could be like all acquired data from collection phase, that is phase two, must be isolated and secure to keep them in their actual state. Next is all acquired digital evidence is duplicated, make cryptographic copies of them. And the physical scene should be recorded based on standardized operating procedures. You have to prevent changes in potential evidence. It may include network isolation, collecting volatile and involatile data. So things that may go wrong in this step. Let's say you acquired a live computer, and in order to preserve it, you must take memory dump. So memory dump is about dumping the content of the RAM, random access memory, which tests the current processes in execution or the live processes in execution. Let's say if you acquire a hard disk out of a computer which is switched off, you must perform disk imaging, which is a bit by bit copy of the content of the hard disk. We're going to see a short video on that shortly. So until this step, step three, you have all the required data, and now you head back to the lab for the remaining analysis and examination part. Examination. So here is what forensic analyst would come into the picture. And what he basically does, or she basically does, is the process of extracting and analyzing the digital evidence. Extraction is recovering data from media or devices. We have a detailed recovery section later in the slide. Analyzing is making sense of the data after extraction. It's like talking with the data in order to understand what this entire system is about. What did the attacker do, or what were the traces of evidence which are left, and now it's analyst's job to make the meaning out of it, right? So it is important to understand how there could be different types of data which analysts might be coming in, in possession of. And we're going to see like how there could be data in rest, data in use, and data in transit, and how to deal with different sort of these kind of different types of data. All right. So one challenge at examination phase is to maintain the integrity of data. And for this, we have certain fancy physical or software devices, I would like to say, and these are called write blockers. So write blockers is any tool that permits read-only access to data storage device without compromising the integrity of the data. As I said, it could be both software and hardware in nature. Let me try to show you how those things are. Yeah, this is a nice picture. So this is a write blocker device. It's physical. We also have software write blockers, and it is connected to this hard disk. I'm sure they are trying to get data out of this hard disk, and by connecting to a write blocker, what it potentially does is it prevents any changes in the time. It prevents any change. So since it is a read-only access, you can just read the data out of it, and by any chance there's no way you can alter the data in any format. So that is why it comes in very handy when you go to a crime scene or when you have data to analyze. All right. What are certain sources of data where you can go and look out for it? It could be networks, servers, personal computers, laptops, cell phone, routers, GPS devices, tablets, right, and RAM. There's so many devices out there in the market. It is very important to be updated about all these devices and how do they. That's why I mentioned in the beginning it's important for a forensic investigator to know how to play defensive as well as offensive, right? So sometimes you also get a very important data in the BIOS itself, which is basic information, basic input output system. Let me see. So sometimes it tells you like how at what time the booting started, the system date and time, right? You could see the these are certain piece of evidences. We could see like when was the last time the system was turned on, when was the last date it was turned on, and there is a specific version of BIOS in traditional systems. In modern systems, however, BIOS is replaced by UEFI, which is Unified Extensible Firmware Interface, right? And you can easily see this information by pressing F2 or F11 on your keyboard, right? So once you go beyond the BIOS, you will enter inside the system, and inside the system, you would come up with different different sort of file formats such as PDF, document, Excel, video sometimes, and images, right? And in fact, there's VoIP, which is Voice over Internet Protocol, and you have to collect data from these sort of protocols as well. There are real-time broadcasts which are happening through multiple software. There's two-way conferences. So always make sure that you go through each and every potential area where you can find the evidence. Next is analysis. So as important as preservation part is, analysis is equally important, because even if you do everything else right, but your findings do not reflect coherency, conciseness, and relevancy, the judge won't admit your report saying it's irrelevant to the case, right? So the best way to do analysis is through forming a timeline or doing a timeline analysis. So timeline analysis is about creation of an accurate history of events related to the incident under investigation. If I get a chance to, be more specific about certain concepts of this presentation, I can assure timeline analysis itself is going to take like an hour because it's such a broad concept. What I can do is I can show you how does it look like. Autopsy is one of the open source software, as I mentioned to you. It really helps you. So if you can see on the screen, it tells you, it sorts a file based on file names, file sizes, file content, creation date, last modified date, times, right? So having this timeline, it basically catalogs even the deleted or erased files as well, right? So having this kind of report tells you like what it may help you in answering some of the questions like what programs were executed, which files were downloaded, what files were clicked on specifically, what directories were open, and which files were deleted, right? So that is why timeline analysis is again very important concept in any forensic investigation. The last step of the entire forensic model is the presentation. Presentation is important because it is going to be used for legal and administrative purposes. It should be complete, detailed, and of evidential quality, because it's mostly likely to be submitted as evidence even if the case goes to the court. Discuss the findings in your reports and present it in the layman's terms, because sometimes, have if you talk too much technical in the court, it's going to be tricky because judges and jury members might not possibly be technicians. You have to provide standard operating procedures or SOPs that are used in your lab. You have to follow checklist of best practices for you and your employees to follow. These can also be submitted as a part of your report. You also have to check the validity of forensic tools and if they're updated to the newest version. Show them artifacts if necessary. Presentation is going to be very, very important step because that's a final step that you're going to show in the court of law. Okay, so this until now we discussed how investigator is going to follow the standard procedure, standard model, and rest of the presentation is mostly revolves around the technical aspects of what we discussed. For example, in the examination phase, I was telling you that an analyst would occur with multiple states of data, and it's necessary to know like how to deal with the certain state of data and how to deal with other state of data. So we have three major categories with us. One is data at rest, data in transit, and then data in use. Data at rest refers to the data stored on a device or backup medium in any form. It can be data stored on a hard drive, like external hard disk, backup tapes, in offsite cloud backup at times, or even on mobile devices. What makes a data at rest is that it is inactive data, right? That is not currently being transmitted across a network or actively being read or processed. So data at rest is typically in a stable state. It is not traveling within the system or network, and it is not being acted upon by any application or the CPU. So if you want to seize data from any of the data at rest medium, the procedure that you would apply is called as disk forensics, or if mobile forensics, if at all you're dealing with the mobile phones. Data in use, on the other hand, is any data that is being currently processed by applications as the CPU and memory are utilized. For example, you work on shared doc, Excel, PowerPoint all the time. It's the data in use because it is being generated, updated, appended, or erased at the same time. It also includes data being viewed by users, accessing it through various endpoints, which make endpoints a point of threat. Data in transit is something which actively exchanging between a network computers and ports. It traverses a network, maybe internet, or if you are a part of a company, then intranet, or resides in the memory temporarily. So when you focus on data in transit, something that you would like to call it is it's some termed as network forensics, right? Next we have is like what do we do or how do we deal with the data when it is at rest? As I said, it's termed as disk forensics or mobile forensics. There are two major techniques which are used: disk imaging and disk cloning. And I would like to show you a quick video on these two things so that the concept is more clear to you guys.
Those things people seem to have typing in all caps style opinions on. I mean, remember how much controversy there was when scientists Xeroxed Dolly? Fortunately, though, no one's going to protest outside your house if you decide to clone a hard drive or SSD. But what exactly does cloning a drive mean, and why might you want to do it? Well, it's hopefully pretty obvious that cloning involves copying something. In this case, everything on one drive to another drive. But there's a bit more to it than that. You see, when you fire up your drive cloning software and press go, it will duplicate the data from your old drive onto your new one, sector by sector. So not only will you have all the same files, but they'll be arranged in the same physical order, including free space and any fragmentation that was on the drive, which you can learn more about up here. But hold on a second, Luke. What if I want to back up my drive? Why can't I just copy and paste everything over using File Explorer? Great question. And if the data you're trying to protect is stuff like videos, documents, and save games, then yes, simply copying everything over without any special software is a perfectly good option. Go ahead. But if you're trying to back up your boot disk, the one that contains your operating system, your settings, your programs, your save games, whatever else, simply playing the copy paste game won't do. As many of the files you need for an exact backup won't be accessible within the operating system while your computer is running. And many modern programs have protections in place that will prevent them from running, or they simply weren't designed to operate properly if they are copied in this manner. However, cloning software will ensure that you catch not only all of your files, but also things like program configurations, partition tables, and the boot record. This way, if your existing drive fails, or you're just migrating to a new one that's bigger or faster or whatever else, you can plug right in and keep on computing seamless. A closely related solution is to create a disk image, which is slightly more complicated. Instead of making an exact clone of a drive onto a new physical device, an image takes a snapshot of your disk, including the boot record and other data that isn't normally accessible, and saves that in a special image file on a different device. If you want to boot from it, you'll have to restore the image to a third drive or back to your existing one using special software. If you're recovering from a catastrophic failure, system crash,
So this was something I wanted to mention. I'm sure you'll be clear with the differences between disk imaging and cleaning. Disk imaging and disk cloning, and we can save ourselves a little time from the theory here. But if you have any questions, you can always put this in the chat, and I would be more than happy to answer those. Next we have is network forensics. So there, the module is dedicated to data in transit specifically. That is when data is being actively transmitted between network computers, and ports. Also, it is a very specialized field of forensics, as I mentioned before. So you have different methods of acquisition. I try to list them very nicely over here. First of all is Ethernet. So if you're part of an organization, it's natural for it to perform surveillance. And if you're just browsing internet from your home, it's natural task for your ISP to put a surveillance program on you. So how do they do this? Through logs, of course, which gets recorded on routers, firewalls, browsers. So as a forensic investigator, your tools are sniffers and packet analyzer. Put the Ethernet LAN on promiscuous mode, and there you go. You can have the same kind of functionality as your ISP or as your organization have on you. Next is sysinternals. It's like a teeny tiny Linux for Windows. These tools give advanced information about the host, utilities, and sometimes troubleshooting as well. The best part about them is that they're portable. You don't even need to install these programs on PC. You can always stick them on a flash drive and use them from any PC. Next you have is PS tools, is another set of powerful utilities that perform all sort of administration tasks, both locally and on remote computers. So of course, remote desktop can be used to connect to any Windows computer and can actually see the desktop and do anything that you would do locally. But PS tools utilities would allow you to do many tasks from the command line, or better, a script that you can reuse anytime you want. Next is IDS, IPS, honeypots, which are like favorite for any technical person in a computer environment. IDS is a passive monitoring system which examines vulnerabilities in the system, the integrity of files, and analyze patterns based on already known attacks. It also automatically monitors the internet to search for any of the latest threats which could result in a future attack on the organization. IPS, on the other hand, it's kind of an IDS, but it has this additional responsibility. It is an active monitoring system which just doesn't monitor but also act upon it. IPS acts as a firewall too. IPS scans network traffic and to find threats using known exploits and attack vectors. Honeypots, these are like false setup of a network to identify the incoming attacks on them. It is deliberately configured with known vulnerabilities in place to make a more tempting or obvious target for attackers. Goals of setting honeypots can vary widely as well, like ranging from defense in depth to academic research, something more of what I do in my lab. And based on sophistication of technicality, we want that there's a low interaction honeypot and there's high interaction honeypot as well. Then there are firewalls. It sits between a network such as the internet and the computer, or like a local network. Its main function is to block unsolicited incoming network traffic. Right. Again, if you want, I can always present firewalls in much detail, and it's if not less, it's more than 1 hour session on firewall itself and how it is important uh, in the forensic, investigation processes. Next you have is event log analysis and sources. We are talking about multitude of events which occur on hourly basis on any platform, be it Windows or Linux or Mac OS. These events contain a lot of useful information about the systems and its users. And undoubtedly, it is one of the most valuable assets in IT security intelligence. Logs can give you a general overview of your network and let you gain powerful insight into its vulnerabilities. Almost every device, whether physical or virtual, is able to generate logs these days. Raw generated logs coming from different vendors can be in different format and severity type, which is, of course, a challenge for forensic people to how to communicate with all of these different kind of platforms at once. So if I take the help of Windows platform and go to event viewer, I would be able to see that there are application logs, security logs, setup logs, and these are specifically meant for very specific functionality. For example, application logs tells you about applications or programs and related error logs. Security logs tells you about the successful and unsuccessful logon events. And I think half of my life is being spent on investigating security logs alone. System logs tells you about the Windows system components and events like driver failures. Forwarded events will tell you events collected from remote computers, and then there are application and service log. So these are certain major events that may generate logs for you: malware, web-based attacks, web application attacks, phishing, spam, denial of service, DDoS, ransomware. So just try to give you a very brief list, but it's not exhaustive. You can always add to this list. It's just to give you an idea that how these kind of events can generate logs for you on your system. I think this is the last category for us today, anti-forensic detection. It's about how you can recover deleted files from a system. So while fetching evidence from hard disk, you must be familiar with the idea of operating system and the file system on active suspect machine. What you have to take care of is the size of the sector. Sector is basically an area of one of the disk platters, and it's defined by two radii. If at all my mouse is moving on the screen, you can see that blue area enclosed by two radii. The sectors are contiguous on a disk. However, file systems look at clusters and not the sectors. So a cluster can range from 1 to 128 sectors. They need not be contiguous. But today, clusters are called as more like allocation unit. So if you are seizing a hard disk, which was like traditional hard disk, one sector is going to be 512 bytes, but more hard disk as these are appearing in today's generation, these are 1496, like 4096 bytes, right? So always make sure what's the size of cluster, what's the size of particular sector you are looking at. It's greatly going to affect your forensic investigation procedure, right? So what all can be recovered? You can always go for known files, like these are the visible files which are on the system, like PDFs, images, audios that we generally, go onto the documents, maybe go onto the D drive and see what are, uh, you know, visible files out there. Then there are deleted files which you can easily found in the recycle bin, right? But then there are certain files which you think that you would shift delete and would not be no one would ever be able to recover that, and that's lost concept. Of course you can recover each and everything, given that you do not override that particular area of sector again and again. it just can become complicated to recover it, but there's always a possibility. It depends on the sophistication of the software you are using for recovery. But yeah, it can always happen. Slack space. It's one of the areas of disk at the end of cluster, but not actually used by a current file. It will often contain data from a previous file in that location, or sometimes from the memory of the computer at the time it was writing. And there is unallocated space, like free space, which is not being allocated to any of the drives. And then there are compressed files and sectors. So there are a lot of tools available to do that. I remember back in my master's, we had this huge Fred kit as opposed to Freddy, which is portable and you can take it literally to the crime scene. Freds are like these different, giant servers which had all these multitude of softwares. Hex editor is one of them. It is used to look at the hex content of the files. You can use Engage forensics, which is crucially and which is important for any forensic investigation. Then there is volatility, autopsy, which is open source, right? And I think it should be the last one, identifying perpetrators. It's not the only way, but you can also go through other ways, but that's the most interesting part. That's why I like to do, go through live system checking through Nmap in Kali Linux. What I do is I check for live systems, open ports using different types of scans. These scans are listed down here very nicely, right? So what you essentially do is, as a part of that scan, you send a malicious payload using the open ports, and then you create a backdoor. If successful, you gain entry. If not, you try with different ports and with different payload, right? You could do banner grabbing on Kali Linux. It's important to check for the particular OS version that you are testing on, and you could do vulnerability scanning with Nessus and Akinetics. There's a lot of components attached to forensics, but in this presentation, I really tried to compress it as much as I could, and I would love to do a demo session in the next slides. But I think that's all for today, and I would love to answer any of your questions. I think I don't see any questions, so I'm gonna. I would encourage you to ping me on LinkedIn if you have any questions related to the slides that I've shown. If related to any other field, I would love to answer that. Yeah.
Thank you so much, Yancy. It was a great session.
Thank you. Thank you so much, Vandana.
Great. So, as Yancy said, if you have any question, you can reach out to her or both the speakers that we had today for supply chain management and security or risk management, and then DevSecOps. Feel free to reach out to us anytime, or if you want to speak, we will meet next month. For this month, we had multiple sessions and wonderful speakers. So, we will meet for our monthly session next month. But yes, there's something that I missed, that on Tuesday we will have a wonderful speaker who will be speaking on cloud. So just wait for it. We will be announcing by tomorrow, and you will hear her name. I am a big fan of that person, and eagerly waiting for that person to speak. So let's meet next week on Tuesday, and for the monthly connect in December midweek, and we will share the details. Thank you.